is that graph? That graph is a line, I guess a quarter circle. It's probably a quarter circle, so we can find the area, and then a couple more line segments. Oh, in fact, the graph of the function f consists of a quarter circle and line segments. So this is the graph of f. And g of x is the integral from 0 to x of the function. So let's put in words what that means, because I think that will help us understand this thing. So I've got a picture, so I'm not thinking antiderivatives. I'm thinking, how are we going to find an integral if we have a picture? Area under the curve. So this is the area under f from 0 to x. So g of x is the area under the curve from 0 to whatever x value you're at. So g is like the accumulated area from 0 to wherever we're looking. Yesterday we had accumulated rate equals total change. That's kind of the same thing here. We're going to accumulate the area, and that'll be our answer to g of x. So initially we can just kind of just plug them in and see what happens. So g of 0, right, whatever's in parentheses next to g goes in for x on the other side. We're not used to having to plug in x as a limit, but that's what we do here. So g of 0 is the integral from 0 to 0. Well, I can probably stop there, right? What's my answer going to be? 0, because the area under anything without any width is going to be 0. So g of 0 is 0, because there is no accumulated area if we start at 0 and go to 0. G of negative 1. So that would be the integral from 0 to negative 1 of f of t dt. Anybody got a problem with that? It's backwards. So how can I make it not backwards? Make it negative. So I can flip the limits of integration and make it negative. Now, again, if you're really careful, you could avoid that. But eventually you'd have to throw a negative on there somewhere. So if you want to look at it and work backwards, you could do that. You would just have to know that you'd have a negative area. So the area under that triangle, 1 times 2 divided by 2 is 1. So the area is 1, but because we went backwards, or because we flipped the limits, either way, our answer is negative 1. And again, I think that makes sense, because our accumulated area, starting at 0, going to negative 1, we're going backwards. So yeah, the area is 1, but we went in reverse, so that negative 1 showed up. So initially, most students start out doing what we did, and like showing the flip, because we always want to go left or right. After you do some of these, you maybe don't even write that step down, and you just look at the picture and you say, well, the area is 1, but I went backwards, so negative 1. G of 2. So the integral from 0 to 2 f of t dt. Why don't you try that one, and then we'll compare answers. It's a quarter circle, so pi r squared over 4. R is 2. So that area would be pi. So my answer is just pi. The accumulated area from 0 to 2 is pi. And then lastly, g of 5, the integral from 0 to 5. Well, we're just adding up the area, so I need to find these areas. Let's see, that would be -1. Again, the area is 1, but it's under, so I'm just going to call it -1. This thing is what is that, a trapezoid? So a trapezoid is the average height times the width. So width is 2, and the average height is 2 and 1. So that trapezoid is 3. Or I guess if you're really careful, you could just count the squares. 1 square, 2 squares, and then those two things put together would make 1 square. So 3, although it's underneath, so negative. So my accumulated area from 0, I like this problem because there's that 1 over there, but that's not where we start. Our function starts from 0. For this one, it could start anywhere. But starting from 0, our accumulated area is pi minus 1 minus 3. And yes, that's pi minus 4, but it's also okay to just leave it like that. It may help you see where it came from.
What about the other one that's behind?
This one?
Yeah.
So good question. What about this one? Well, g of x is defined to start at 0. So at x equals 0. So I don't even look at that. I just want to count the area starting from 0 moving forward. Part B. Find all values of x on the open interval -1 to 5, which g has a relative maximum. G has a relative maximum. Justify your answer. Okay, well, let's justify our answer first, and then we'll use our picture and see if we can figure out what's going on here. So, G has a relative maximum. How do you answer that question? Even without even this picture, just in general, how would you know that G has a relative maximum? When what goes positive to negative? The slope of G, or G prime. When G prime changes from positive to negative. Yeah, because the slope would be increasing and then decreasing. Or, excuse me, the slope would be positive and then negative. So that means the function changes from increasing to decreasing. So that would be a max. Well, I don't have G prime. What I have is G. Let's take the derivative of both sides so that we get G prime. So the derivative of G is G prime. That's what I'm looking for. Or that's what I'd like to know. And then the other side is what we did yesterday. The derivative of an integral. Those cancel out is a good way to say it. So I'm left with just f of x. Because the derivative of an integral is right back to f. And I didn't have to worry about a chain rule thing. I mean, I guess I should always worry about it, but the derivative of x is just 1. So f of x we have the graph. Like, we know what f of x is. So that graph, it's the graph of f, but since f is g prime, it's also the graph of g prime. So let's just label that. So now we have to kind of shift our thinking of we were thinking that as a graph of the function, and it is, but now it's also the graph of a derivative of a different function. So I want to know where g prime changes from positive to negative. So from the graph of g prime changes positive to negative at x equals 2. Therefore, g has a relative max at x equals 2. So it puts together a couple different things. Something we used long ago, relative max when g prime changes positive to negative. And we don't really have g prime, except that we actually do have g prime, because if we take the derivative of an integral, we get right back to where we started. Part C, find the absolute minimum of g on -1 to 5 and the value of x at which it occurs. So it wants the y value and the x value. Justify your answer. Do you remember what we need to remember when we're talking about absolute mins and maxes? Let's back up a second then, or look at that in a minute. So minimum would be where g prime changes the other way, negative to positive. That would be a relative minimum, so a potential absolute minimum. So where does g prime change from negative to positive? Nowhere. Maybe that reminds us that if we're looking for the absolute minimum, there aren't any relative minimums. So what do I have to check? When it says absolute, that's the reminder to check the endpoints. So find the relative minimums, but also check the endpoints. This one was nice enough to not have any relative minimums. So I'll check the endpoints. G of -1, G of 5. And I wonder if this is an old AP test question, because they do things like this quite a bit. It's like, oh man, now I got to go find g of -1. Except that we already found g of -1. So taking the AP test on the free response questions, not always, but a lot of times they use previous information so that you don't, it saves you a little bit of time if you recognize that, wait a minute, I already found g of -1. It was -1. G of 5 was pi minus 4. Oh, that's kind of tricky. Which one of those is smaller? -1 or pi minus 4? Let's see. Pi is, we just had the song, 3.14159. So this is very approximately -0.9-ish. So we have an absolute minimum of -1 at, oh, that's kind of lucky there. They're both the x and the y value are the same. So if you got them backwards, no one would ever know. But the y value is the minimum value. The x value is where it happens. And this question asks for both. Yes, sir. Yeah. Part D, find the x-coordinate of each point of inflection of g. Justify your answer. Well, a point of inflection of g would be where g double prime changes signs. So where the second derivative changes signs. do I know anything about G double prime? Let's see. G was the integral of f, which meant G prime was f. So what's G double prime? F prime. We're just kind of taking the derivative of each side as we go down. And f prime means the slope of f, which is the graph that we have. So we have the graph of f. We can find the slope of f, which is also equal to G double prime. So G double prime changes signs where the slope of f changes signs. Alright, well, I've got a graph of f, so I can just go look at my picture. And I'm looking for where the slope of the graph changes signs. So what is the first x value where the slope of f changes signs? 0. Positive, 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 and then it flips to negative. So x equals 0 is one of my points of inflection. Let's see, negative, negative, negative. Is there anywhere else where the slope of the graph changes signs? Yes. And what would that be? X equals 3. I can't count that high. 1, 2, 3. Changes from negative to positive. So x equals 0 and x equals 3. So this is kind of the big deal for this lesson today. They're going to give you g as some integral, which means the derivative of g is back to the original of f, and the second derivative is the first derivative of f. And you don't really memorize that, you just kind of reason through it, and then they'll ask you questions. But once you have this written down, you can usually figure out everything else, as long as you still remember all the old rules about increasing, decreasing, point of inflection, all that stuff. Let's try another one. Let g be a differentiable function defined -5 to 5. Here's our picture. Such that g is the area from -1 to x. Okay, so we got to be careful this time. We're starting at -1, kind of our starting point here. Which is good, because if they started this one at 0, we wouldn't be able to do the problem, because you'd be looking at a piece of a circle that we don't know how to find the area of. So they put it at the middle, the center of that circle, so we'll be able to find areas. Right, g of 5. So that means the area from -1 to 5 of g of x. G of -5 would be the area from -1 to -5 of g of x. So why don't you try both of those, and then we'll compare answers. The first one's going forward, so that's at least somewhat helpful. The second one's going backwards, plus there's area underneath, so there's all sorts of negative things to worry about. All right. Job 1 is probably just fill in all the areas, and that'll make it easier as we go. So the area from -1 to 5 would be, so I'm moving forward, so I don't have to worry about positive, negative. Well, I mean that one's underneath, so that's negative. But -pi plus 4. I started to divide that up into two triangles. That's where I drew that line, and then I realized it'd be easier to just do one big triangle. But it would have been 2 and 2 if you wanted the smaller triangles. Right, from -1 to -5, you can go backwards and flip the signs on the fly if you're comfortable doing that. So that would be pi minus 3. if you're okay with that. If you don't like going backwards, and you say, you know what, let's go forward like we're supposed to go. So I'm going to flip the signs and make it negative from -5 to 1. So that would be negative. And then now I can go forward, 3 minus pi. Or negative 3 minus pi. And this is a perfectly good safe stop, so you could leave it there and be okay. But I wanted to take it one step further to show that if you are comfortable moving backwards and just flipping the signs kind of as you go, positive pi, -3, because we're going backwards, positive pi, -3. So either way, again, some people flip the signs every time because they can't stand the thought of walking backwards and then flipping signs, like too many negatives. Other people are comfortable walking backwards, and that's okay. Either one. Part B, determine all relative maximums and minimums of G. Justify your answer. I'm going to justify my answer first. So max of G would be when big G prime changes positive to negative. Yes, I think about it every time. The minimum of, I got to use big G and little g, of big G is when big G prime changes negative to positive. Yeah. So I need to know something about big G prime. Well, big G is the integral from -1 to x. So if I take the derivative of both sides, because I want to get G prime, I guess we can show the work here. I mean, it's not much work to show, but show what we're doing. Take the derivative of both sides. G prime is equal to little g of x. It happens this way every single time in these problems, so you get the hang of it after a little while. So this graph of little g is also the graph of big G prime. And you don't have to label it, but I like to label it because now it helps my brain switch gears. Like, yeah, this is the graph of G, but it's also of little g. It's also the graph of big G prime. So when big G prime changes positive to negative, that happens at, let's see, from positive to negative, that happens at -3 and nowhere else. G prime changes negative to positive. Well, this is the graph of G prime. So that change happens at negative to positive at x equals 1. But again, the main point of today's lesson is borrowed from yesterday's. If you take the derivative of an integral, you get back to what you started from. Points of inflection. Well, let's take what we just did and go one step further. The second derivative of G would be the first derivative of little g. Which, if you wanted to write it, you could write that as the slope of little g. It's not absolutely necessary that we expect you to know what that means, but if it helps to write it out to help you know what you're looking for on the graph. So justify your answer. So POI happens when G double prime changes signs. And I've already said that G double prime is these other things, so I don't have to write out that that's where G prime changes signs, that's where the slope of G changes signs. If you need to write that out to kind of convince yourself, you can, but we're looking for where G double prime changes signs, and we've already explained what G double prime looks like. So now I can go to my picture, and the slope changes at what value of x? Careful, not -3. It stays negative at -3. -1. Anywhere else? At 3. I like these last questions. These look hard, but they're not. Because G prime, what is capital G prime equal to? G, little g. So if I want little g of negative 1, this is the graph of G. What's little g of negative 1? Negative 2. It's just picking off the value off the graph. So I don't want to say there's no calculus, because there's a whole lot of stuff going on in the background here that we kind of already covered, but to answer this question, all you're doing is picking a point off the graph. Capital G of 2 is equal to, capital G prime of 2 is equal to little g of 2. So we look on the graph, and that's 1. Capital G of 3 is equal to little g of 3. We look on the graph, and that's 2. So those are the easiest questions on the page if you made the connection between capital G and little g. All right, the back it's the same thing. It's just more practice on the same thing. So we'll go a little faster and hopefully finish before the bell rings here. Let capital F equals the integral from 0 to x of little f, where f is the function graphed above. So I'm going to label that graph f of x. Maybe I'll label it underneath it as well, just so I can see it both places here. Evaluate integral from 0 to 2. Okay, we can do this pretty quickly. From 0 to 2, that would be negative 4. From 0 to 4, ooh, careful. This one's negative 1/2. What's the area of... Oh, that's not negative 1/2 either. Because it doesn't cross where we think it should cross. I don't like this problem. Oh, I see. On my previous notes, I changed the picture to make it work better. Let's put it to right there. This will make life a lot easier. That's got to be a mistake. So now it's 1/2. You're right. It was going to be. I don't think it was going to be a third. I think it was going to be like a fifth, because that slope would have been 5/2. Ugh. But we're not worried about it now. We changed the picture. No, you can't do that on the test. That's always a good question. So this side now is 3 times 1 over 2 would be 3/2. So from 0 to 4 is negative 4 minus 1/2 plus 3/2. And why not just leave it like that instead of messing this up any further?
What's
Yes?
the little triangle that's like negative instead of 1/2? Wouldn't it be 1? Because it's the height.
You're right. It is 1. Man. Did I mess up the 3/2 as well, or is that one right?
That was.
Got whiteout upon whiteout here. Maybe I may have to re-record this one when I teach third period. Well, to 4 it's 3/2. There's also 3/2 on the other side. Right? And then this one on this side is negative 3/2. Negative 6. -3. And this one was -1, now that the whiteout has dried. I know calculus, I just can't do geometry. That's right. Calculus is easy, geometry's hard. So I changed my answer here, -4, -1, plus 3 halves. And not, you could clean that up, but why bother? Just leave it as is. From 2 to 4, a different starting point, so be careful here. From 2 to 4 is -1 plus 3 halves. Especially since I've got everything labeled, this should be a little bit easier now. And from 5 to 10, I'm just adding up those areas. And why even mess with it? Like, just leave it like that. All right, the real point of this, f of 0, but f is just the integral from 0 to 0. Oh, I can stop right now and know what this answer is. All right, the area from 0 to 0, done. There's no area from 0 to 0. F of 2 is the area from 0 to 2, which we already found. So we kind of did that problem under a different name. F of 7, so that's the area from 0 to 7. So -4, -1, plus 3 halves, plus 3 halves, minus 3 halves. And then how do I get from 6 to 7? -3. And I guess that all cleans up to something, but somebody else can clean that up if they want to. We're safe stopping. Find an algebraic function for f. Hint, it will be a piecewise function. How about no? We're not going to do that. No. Where does f have a local maximum? Well, that would be where f prime changes positive to negative. And then here's the whole point of the worksheet. What's f prime equal, capital F prime equal to? Big F or little f? Little f. So that graph that we have up there, it's little f, but it's also the derivative of big F prime. All right, I think you can answer the rest. And then the worksheet is just more practice of the same stuff. So it's not hard, but it is a little bit tedious. Be careful. Give it a practice. And we'll do more practice of it on Monday. So if it seemed tricky, we do have 2 days of this to hopefully figure it out.